If you watched the previous videos, I think you can get from words the data you want down in a data frame. But if you want to replicate the replication crisis paper of Theis, Kelly and Lasse, there are a trick that I didn't see, and it is a little bit hard to see it when you work from Python. And that is that there are some restrictions you have to impose to get the right rows loaded, so to say. So, for instance, you only want one security per month, and if you only want that, you should restrict the variable or the column. That's basically the column value of ops main to be equal to 1. If you only want observations for common stocks or rows from common stocks, observations from those, you should set the primary sec variable to 1, and so on if you only want prominent exchanges and primary listing 1 per month. And I didn't when I started out, so I got too many data downloaded, and I talked to Theis about what the problem could be, and you just have to impose this. So that's what I want to show you now, how you get rid of this problem here. Let's import the package and form a connection to Words. And here we are, and then let's just select. I'm just counting the rows I get up from this query here, and we take the contrib database or library and the global factor table, and to limit the output, I just take the output from Denmark, where the country variable is equal to Denmark. So let's see how that turns out. It takes a little bit more time than I thought. Well, here we are. This is the observations you would get if you don't restrict anything. However, we need to set I'll explain below what is going on here, but we need to restrict the observation main to 1 and the primary sec to 1, and so on and so on. And more also in the database they have updated the data, so if we want exactly the rows they used in the paper, we will only want observations from 2022 and before that. So that's the restriction here. End of month should be before this date here. And I formulated like this with these multi-line string constructors or citation marks, and so I have these two strings here, and I need to insert these two strings into this string we had before, and we can do that with having an if. If you don't know, you can just write an if in front of a string, and then you can, with these curly brackets, you can simply insert the variables if they are strings, and their value will simply be inserted into this place here in the previous string, and that's called, I just call it f strings. That's what most people do, but more formally it's called formatted string literals, so to say. So, and this is what I will do below many times, have these f strings, so that I will write restrictions as in small pieces of strings, and then I'll just insert the string in the SQL query here below, as you see here. So if you do this, we can, let's see what happens, and there you can see the number of observations is considerably lower than before if we impose these restrictions. The date restriction is actually not that important. We can try to delete it here and see what happens. You remember this number here, almost 16,000, and it's still almost 60,000. So you can see that these restrictions up here, they are more important than the date restriction. Also, let me show you a trick to get the right variables you want. You can see I've the name of the columns. I've just picked some of them in the dataset, and then I'm using this if string functionality, or whatever you would call it, here to separate the name. I think it's nice to have the column names separate from the rest of the SQL query here. And I recently started a career as web developer, so you should have access to this stuff here somewhere close to the video, and here you can simply copy paste the variables you're interested in, if that makes things easier to you, and you just can copy paste it into here, and then you can run. If you only want a subset of the columns in the data, you can subset it here, so you only get the ones you want. If I managed, I will try to have a list of only the variables used in the paper. I think there are 153 or 6 or something like that. What I showed you here is all 400 variables, which perhaps you are not interested in. Let me also show you how you can have more countries in the query if you're interested in more than Denmark. I have a string here. It's pretty obvious what is happening. You should note, however, that they are all, the restrictions are separated by or, which is, the fact is that, as I write down here, that and is stronger than or. So in order to avoid any problems, I simply just surround all the ors here with parentheses, so that it would be the country variable should be this one or this one or this one, as it can obviously not be all of them at the same time. So it's different from the ANDs restrictions. And then again, you should note that these should be, they have a citation mark around the value here. You might think that it is a bit inconsistent because the columns were not, as you saw up here, they don't have any citation mark around them, and it is perhaps a bit inconsistent, but I guess I think columns are names, and therefore they are strings, so for some reason they haven't been completely consistent here, but I think, or perhaps it's just easier to have the column names not included with these citation marks here. But yeah, that's how it is. Finally, a memory saving trick that can be used in a lot of situations. Here the idea is that instead of having a string where you are loading a lot of countries or data for a lot of countries at the same time, I specify an array here, and then for the first country I make a for loop. So for country 1, in countries, we load the data from that country, and then we do some calculations. You're probably not just printing out the shape of the data frame, but if you can split your calculations up in different parts where you can do the calculations for each country at a time, this will save you a lot of, you don't then have to load in the entire global factor table here, which is crashing most computers, or not crashing, but you can't just load in all of this data without crashing at least Python. So this is a way around this problem. If you have really big data, then I think this trick will benefit a lot of you if you can split up the data and do independent calculations. For instance, here, if you can do it for every country, then you only need to load one country at a time, and then that will save you a lot of memory. Maybe you can do the calculations for 10 years at a time. You cannot for this paper here, the replication paper, but in some cases you might be able to do a lot of calculations for 10 years. So you just load the one period of 10 years of data, and then the next 10 years of data, and then obviously you will have to adjust the date restriction similar to this stuff going on up here. So let's just look at what is going on here. There you can see we loaded the first country, printed out the size of the requirement, and then the next country, and the last country is there. And obviously you will probably not want to just print the size of the data frame, but your Nobel Prize winning calculations will be done here for every country. So just a tip to save some memory in a lot of cases. One tiny thing I forgot to tell you, note that these elements in the array are strings with citation marks, as they should, but down here when we insert them, there are citation marks again. And that's because this if string works as that maybe it's a Python thing that it just inserts the letters of the string. Obviously it doesn't insert the citation marks, but SQL in its statement need the citation marks here. So we are using, or we are having citation marks twice here in this case, but you will figure out how to do it.